Okay, now determining the types of polar curves. Determining types of polar curves. Polar curves from the given equations. Okay, number one, equation of the form R is equal to A sine K theta, and R is equal to A cosine K theta. Okay, where K is the positive integer, where K is a positive integer. Have graphs which are called rose or petal curves. Okay. The number of petals is equal to K if K is an odd integer and equal to 2K is K 2K is an even integer. If K is equal to 1, there is one petal and it is circular. Sample. R is equal to 3 cosine 2 theta. Therefore, K is equal to 2. Therefore, we have 4 leaf rows. Okay. What if the given is R is equal to 2 sine 3 theta? Therefore, K is equal to 3. K is equal to 3. And therefore, you have 3 leaf rows. Okay, now, number 2, the graphs of equations. Number 2, the graphs of equations of the form R is equal to A plus minus B cosine theta, and or R is equal to A plus minus B sine theta are called limacons. Okay. In the special cases in which A is equal to B, the special cases in which A is equal to B, the graphs are called cardions. Okay, examples. Okay, R is equal to 3, 1 minus cosine theta. R is equal to 2 times 1 plus sine theta. Sine theta. And R is equal to 2 times 1 plus cosine theta. Okay, number 3. The graphs of the equations of the forms R squared is equal to A squared cosine 2 theta, or R squared equal to A squared sine 2 theta are called lemniscates. Then we have R squared is equal to cosine 2 theta. R squared is equal to 4 sine 2 theta. Okay, example. Okay. Analyze and trace the curve. Ito yung and the curve R squared is equal to 4 cosine 2 theta. Then we have R squared. Given equation is R squared is equal to 4 cosine 2 theta. Therefore, this one is equal to A squared cosine 2 theta, or that is 2 squared cosine 2 theta. Okay, for number 1, for the symmetry. Okay, letter A, symmetric with respect to OX, since theta can be replaced by negative theta. Letter B, symmetric with respect to OY, since theta can be replaced by theta minus 1, by theta minus, pi minus theta. Letter C, therefore, symmetric with respect to the origin. Or pole. Okay, now, for the intercept, number 2, intercept points. Intercept points. We have theta, 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Then we have your R. Sure, we have 2. 0 degrees, R is equal to, if your theta is equal to 0 degrees, what would be the value of your R? 2. What if the given theta is 90 degrees? What would be the R? Okay, therefore 90 degrees, 0. Then, what if the given theta is 180 degrees? Okay, therefore 180, R is imaginary. What if the theta is 270 degrees? Okay, therefore 270 degrees, R is 0. What if the theta is 360 degrees? What is the value of your R? Now for the additional points, so that we can draw the given. We have theta 30 degrees and theta is 60 degrees. What would be the value of your R? Okay, 30 degrees, R is 1.4 for the square root of 2. What if the theta is 60 degrees? Okay, therefore this one is imaginary. Now we have R squared is equal to 4 cosine 2 times 30 degrees. Of course, your R is equal now to 1.4. And R squared is equal to 4 cosine 2 times 60 degrees. Therefore, R is equal to imaginary. Okay, this one is the figure for this problem.